Powers of exponents. It says simplify. Get it into the simplest form. It says your answers should be only in positive exponents. I have not taught you negative exponents yet, but they will be coming shortly. So let's look at problem 1. We have 3a squared, but all of that cubed. What does that look like? It's 3a squared times 3a squared times 3a squared, because you need 3 of them. And so you have 1, 2, 3 of them. So what else does this really look like? It also looks like 3 times a times a times 3 times a times a times 3 times a times a. You're multiplying everything together. So we have 3 times 3 times 3, which happens to be 27, and we have 1, 2, 3, 4, 5, 6 a's. So here's my answer, 27a to the 6th power. Looking at the next one, we have 3x to the 4th power, but all of that to the 4th power. So what does that even look like? So this is what it looks like. 3x to the 4th times 3x to the 4th times 3x to the 4th times 3x to the 4th, because we need 4 of them. And if I break it down even more, expand it out, I have 3 times x times x times x times 3 times x times x times x, and so forth. All of it again being multiplied out. I don't know what the x's are, but I do know I do have my 3's, so the again being all multiplied. So 3 times 3 happens to be 9, and 3 times 3 happens to be 9. So 9 times 9 happens to be 81. And I have 4, 8, 12, 16 x's. So we happen to have a rule, and let me show you this rule. So here's the rule. A to the m power to the nth power is when you multiply the exponents together, m times n. So if I look back at these examples, here I have this power. I can multiply to these powers. I have 2 times 3, which is 6, and this 3 actually has a 1 right there, so that is 3 to the 3rd power, by the way. So if I write that out, that could be 3 to the 3rd power and a to the 6th, which means is 3 times 3 times 3 and a to the 6th. And if I look at the bottom example, here I have 4 times 4, which is the 16, and this is 3 to the 4th power, which I have 3 times 3 times 3 times 3. Here's a couple more problems, and again, here's our rule down here. So what does number 4 look like? So we have 6b squared times 6b squared, or 6 times b times b times 6 times b times b. So we are going to have 6 times 6, which is 36, and we're going to have b to the 4th power. Now if we use the rule, this would be 6 to the 1st power, right? So we'd have 6 squared b to the 4th, because we'd multiply those two together. So 6 times 6 is the 36, and b to the 4th power. Look at the next one. So this is what it looks like. And if I use the rule, the 3's to the 1st power again, so I have 3 to the 4th, a to the 4th, b to the 16, or 3 times 3 times 3 times 3, so 3 times 3 is 9, and this is 3 times 3 is 9, so we'd have 81, and we'd have a to the 1, 2, 3, 4, and b to the 1, 2, 3, 4 times 4 is 16. Okay, so now what would this look like, number 13? Well, I could keep writing over and over 3x squared times 2x squared times 3x times squared times 2x squared, or why don't we combine in the parentheses first? So I would have 3 times 2, which is 6, and I'd have 4 x's, and then I can square it. If I did write it out, I'd have 2 of these, or if I simplify them, I'd have 2 of those. So it's 36x to the 8th. Now if I do it by the rule, I would take this 2 and I would have 6 squared, because that's to the first power for the 6, and then x to the 2 times 4 is 8. So that would equal 36x to the 8th power. The next problem, again, I'm going to simplify on the inside, so I'm going to have 4n to the 5th, and I've got it to the 2nd power, and it means I need 2 of these on the inside. So I'm going to have, since it's to the 1st power, 4 squared n to the 10th power. That's 4 times 4, which is equal to 16. So we have 16n to the 10th power.